Okay, so today I'm going to do some recording on the lecture notes. I have opened the lecture notes to be sure we left off. So, like it's a little bit wider than. Here we go. So, a classroom has triangular tables. There's enough space at each side of a table to seat one student. Tables are, or the tables in the class are arranged in a row. The below picture represents a row of 5 tables. How many students can sit around one table? So it says each side of the table sits one student, so there are 3 for one table. We have 2 tables arranged in a row like that, and we have 4 places. And if we arrange 3 tables like that, 5. We want to find an algebraic expression that describes the number of students that can sit around a row of n tables. So we have n tables like this. We get to have 2 people on this end table, and then each table in the middle only allows for one student at the table. When we get to the last table, we get to have 2 students at the end of that one. So, like all of the tables in the middle, so notice how each of the middle tables only gets to have one student at it, and then the tables at the ends get to have students at it. So that's n is the number of tables. We get 1 per student, and then we get an additional 1 at each end. So it should be n plus 2. Once we have a nice formula like that, we can plug in arbitrary numbers. Like if we have 125 tables, we just plug in 125 for n. That gives us 127 students. There are 26 students in the class. How many tables are needed? This is the other way around. We have students equal the number of tables plus 2. We plug 26 in for students. That gives us 26 equals n plus 2, which gives us n equals. Well, it's just a little too much. That works. Okay. Solve simple application problems, expresses linear equations. So here are some hints that let's take a look at. Look for your look for your equal sign first. This is how I've been doing it with you in class. We always look for the word is, or the word are, or the word am, word be. These words turn into equal signs when we translate from English into our standard mathematical symbols. Says find the total. Yeah, words like total are means that everything before is being added. Draw as many blanks as equal to the total and label appropriately. Fill in 1 blank at a time using the remaining keywords. Use the same variable in each blank. Solve inter. Okay, so let's this problem here. A $57,000 estate is be divided between so have here's our 57,000, and then we're going to have other stuff on the other side. Be divided between a husband and his son. So there are two spaces because there are two things that have to add up together to be 7. So that the husband receives twice as much as the son. Find how much each receive. So if the son is X, then the husband would be 2 times X. Oh, why we have a second line here? Let's see what it says. Find your equal sign and total. In this case, equals is the estate. Set up the basic equation. There are 2 people who get the estate. Draw blanks and label. Use the remaining info. Find the correct blank. I guess they decided to use S for son, and that's fine. So we have 2S plus S is 3S equals 7,000. That means that S, can't write on the gap there. S equals 57,000 divided by 3, and that comes out to be 18,000. Yeah. So this is the two most important skills in the class are the one where we convert from a sentence into an equation. So being able to translate this into this is one of the 2 most important skills. The other one is going the other way. Once we have S equals 1900, we really need to be able to turn it back into words. Son should receive 19,000, and husband will receive 2 times that, 38,000. So we want to be able to go from the way that the problem presents itself to us in the real world, usually in words, but sometimes we're not even given that much. We want to be able to transfer that into symbols, translate that into symbols, do the calculation, and then once we've done the calculation, we need to be able to turn that into a solution in words. If you can't translate problems into symbols, you can't use your math to solve problems. If you can't turn those symbols back into a meaningful interpretation, then your solution isn't applicable and you can't use math to solve your problems. Math can solve lots of problems. We can use it to do all kinds of things that are interesting and important. But again, without being able to translate into and out of the symbolic notation, it's it's a skill that becomes locked to us. Okay, let's do another one. A rope 40 feet long is, so there's our equal sign is, and here's our 40 because that's what's on one side of the is, cut into 2 pieces. So here's a piece, here's another piece. We'll fill in that data later. If one piece is 18 feet longer than the other, so we have a piece that is some length and a piece that is 18 longer than it. Their short piece, there's our 18 longer. What is the length of each piece? So once we've translated into this form, we combine like terms, uh, we isolate the variable by moving all of the constants to one side and get, gathering all the variables to the other side if necessary. This one only had variables on one side. Divide by the coefficient, we get the small piece is 11. And that means that the longer piece is 29, 18 more than it. Another one. Rachel and Jack drove 510 miles to the Grand Canyon. So we didn't see the word is there, but Says if Jack drove 98 miles more than Rachel, how many miles did each of them drive? We know that their total drive was 510. We know that what each of them drove has to add up to 510. And we're told this piece of information: Jack drove 98 miles more than Rachel. So Rachel is X, then Jack is X plus 98. Now, could you do it the other way? Could you say that, oh, Jack drove X and X has to be 98 more than Rachel, so Rachel drove X minus 98? The answer is yes, you could do that way. You just have to make sure that you recognize that in the first one, X is Rachel, and when you solve, that number will be Rachel. And in the second way, that number would be Jack instead. So if you can usually set these problems up several ways. And the way that they chose was Rachel is X and Jack is X plus 98. But you could solve the problem the other way. You just have to remember that when you're interpreting your answer, that the variables are you just have to make sure that you're consistent with how you create and interpret your variables. Anyway, we combine like terms, we subtract 98 from both sides, and then we divide by 2. We get x is 206. That's Rachel, and that means that Jack drove 98 miles more at 304. Let's do this problem together. I'm going to leave, of course, some of these non-example problems you should do as homework. I'm not going to do all of them, but I'll do a few of them. So, a school bus can seat 28 students. If there are 6 more girls than boys on the bus, how many boys are on the bus? Okay. So, school can seat 28 students. We know that the total number of seats is 28. This can seat. That doesn't necessarily mean it is seating 28 students currently, but we're going to assume that it is. So we have 28 as our total, and we're told there are 6 more girls than boys. So we'll let boys be X, and girls will be X plus 6. X plus 6, 28. 2x equals 22. X equals 11. That means that there are 11 boys and there are 17 girls. Let's do the last one in this group just because it probably is supposed to be the hardest. Like this is it. Oh, marble bags are very common math questions. I remember doing so many marble bag questions in school on the standardized testings. Okay, so it says there are 85 marbles in the bag. Here are my 85 marbles, and we're told if there are 13 more green than blue, so let's let X be blue, and then we have green, that's going to be X plus 13. Find the number of green marbles and the number of blue marbles. We have this, that's 2x equals, we subtract 13 from both sides, 72. X equals 36, that's the blue. And plus 13 equals 36 plus 13, which equals 49. That's the green. Okay. Now we're going to do a similar thing, but we're going to do it with perimeters. So a long office desk has a length that is 5 feet longer than 3 times the width. We're going to assume a rectangular desk. So the width is whatever it is, the length is 5 more than that, and we're told the perimeter is 26. So we have W plus W plus W plus 5, W plus 5 equals 26. And if you wanted to do 2W plus 2L equals 26, that's fine too. However you want to do it. Get 4W plus 10, 26. So 4W equals 16, and W equals, means W plus 5 equals 4 plus 5, 9. We have a desk that is 9 feet long and 4 feet wide, which seems fairly large to me. Um, I don't know that I have a desk that is, well, I guess the one in my office might be large. Um, Actually, no, I don't think it's 9 feet long because I think if I laid on it, I think that my head would hit one end. My feet would, or might be a little smaller than me. I don't know. A carpet is in the shape of a rectangle. Here's my rectangle. Perimeter is 228 feet. Length is 22 feet more than the width. Dimensions are, well, twice the width plus twice the length. I doing it a slightly different way this time, in case this is the way that clicks better for you. Distribute, we get 2W plus W plus 44, 28. Subtract 44 from both sides, combine like terms. We get 184 minus 4 is 4. 22 minus 4 is 18. Equals 4 goes into 18 4 times with 2 is the remainder. 4 goes into 24 6 times with no remainder. Width is 46. Length equals 46 plus 2, 68. Are the dimensions. Oh, by the way, when it says the dimensions, it's going to be more than one number answer. You're going to have to give both the length and the width. So if you had stopped here, that would have been an incomplete answer. Okay. We have triangle problems. So with the triangle, the 3 interior angles add up to 180. So that's going to be the equation that we use to find answers, is we're going to have all 3 angles have to add up to 180. An isosceles triangle. Isosceles means that 2 of the angles are the same. Like this one and this one in the diagram. An isosceles triangle has base angles that are 4 times as large as the third angle. So, if the third angle is x, that means the base angle is 4 times x, and they all add up to 180 degrees. So that means that we have x is one of the angles, and then the 2 other angles, the base angles are the 2 angles that are the same in the isosceles triangle. One of them is 4x, the other one is also 4x, and they add up to 180. Means that 9x equals 180, and x equals 20 degrees. Now, do you have to put the degrees here in the equation? It depends. If you have degrees here, then you should carry it all the way through, and your variable will equal some number of degrees. If you don't put the degrees in here, then your variable is going to equal some number, but the angle that the x is representing, that angle measure is equal to x degrees. if you put the unit in the equation, then your variable will likely have a unit as part of its value. If you don't put the variable in the equation, this, then your variable at the end will not have a unit. But your measurement angle that you're measuring still does. So you should pay attention to the question and see what it's asking for to make sure that you know if you have to include units or not. One angle in a triangle has a measure that is 3 times as large as the smallest angle. So if this is the smallest angle, then one angle in a triangle has a measure 3 times as large. The measure of the third angle is 25 degrees more than that of the small angle. Those are our three angles. You have to add up to 180. X plus 3x plus x plus 25, 180. This gives us 5x's. Well, 180 minus 25 is 155. X equals 31. And since I didn't put degrees here, they don't go there. They don't go there. But my angles are still, the small one is 31 degrees. The next one is 93 degrees, and the last one is 56 degrees. So my angles are this, but because I didn't put units in the equation, my x value has no units, but my angles still do. If I'd put a degree symbol here, then it would have carried down, and I would have had x equals 31 degrees. We are coming to the end of this unit. Alexis and Thomas drove 512 miles to the Grand Canyon. If Thomas drove 86 miles more than Alexis, how many miles did they drive? So, what is the range of miles? Okay. Okay, so sorry, let's back up a bit. We are using Polya's first principle. This is the understanding principle. So in this section, in this subsection, we're probably not actually solving any problems. We're just figuring out how to set up the problem. So Alexis and Thomas drove 512 miles to the Grand Canyon. If Thomas drove 86 miles more than Alexis, how many miles did they each drive? Do not solve. Okay. I bet that we'll solve this in a subsequent section, but we won't solve it here. What is the range of miles that Alexis could have driven? This question here might seem a little bit confusing. All it's asking us to do right now is to come up with some bounds on the possible answers. Okay. We know that if the two of them are both driving together, and if we know that Thomas drove more, then we know that Alexis can't have driven half, for instance. We also know that he didn't drive the whole way. If he drove the whole way, he would have driven 512 miles more than her. So, we know that Alexis drove at least 0 miles, and at most, half of 512 is going to be 256. And we don't have to be incredibly precise with that right now because all we're trying to do is find upper bounds and lower bounds that will, if we do our calculation and we get to the end of the calculation and it says that Alexis drove 300 miles, we know, oh, I did something wrong. I either set it up wrong or I typed it into the calculator wrong. Just we're just trying to put some bounds on to kind of to be some error checking at this point. We're not really looking to completely solve anything at this point. Identify what the problem is asking you to find. State this unknown by defining a variable. Choose a variable that might help you in remembering the unknown. So we're still looking at this problem, but now we're going to set up, we want to know how many miles did they each drive. So we could say X is how far Alexis drove, and based on the question, we know that X plus, I think 86 was the value. 86 is how far the other one drove, Thomas. So X plus 86 plus X equals 512 describes the situation. So we chose a variable that might help us remember. We stated the unknown by defining a variable. We actually went a step further by writing out an equation, but I don't think that that's too far. So this is an equation that would solve the problem, and we weren't asked to actually solve it. We were asked to just explore and understand the problem. Next one here. A 24-inch piece of string is cut into two pieces. The shorter piece is 5 inches longer than the longer piece. Sorry, the shorter piece is 5 inches shorter than the longer piece. Without solving, if you decided to use the variable x, would x equal the shorter piece of wire or the longer piece of wire? You could do it either way, but if we're looking strictly at this sentence here, it says that the shorter piece is shorter than the longer one. So I would use x for the longer, and then x minus 5 for the shorter, just to be kind of parallel with the sentence. If I care about matching the wording of my equation with the wording of the paragraph, that's how I would do it. Although you could also do it the other way, where x is the shorter and x plus 5 is the longer. To be truthful, I would probably do it that way because I like using addition more than I like using subtraction. What would the expression for the other piece be? Oh, yeah, so x is the longer, means that x minus 5 has to be the shorter piece. And you can explain however your reasoning is. Let's see. So we have a long paragraph here. And so what we're going to do is we're going to check to see what we're asked to do first and then go back. Identify what the problem is asking you to find. State this unknown by defining a variable. Hint. Choose a variable that might help you in remembering the unknown. What it means by that is like often you might take the first letter of what you're trying to look for and use that as the variable name. Anyway, all we have to do right now is identify what the problem is asking you to find. Do that, we'll skim through the paragraph and see if there are any commands or any question marks and go from there. So just skimming over here, there's a question mark. How many hot dogs per hour will they have to sell in order to sell the rest of their hot dogs? So we're trying to figure out how many hot dogs per hour they have to sell, get rid of them all, which means that we have to know how many they have and we have to know how many hours they have. So let's see. Have that many hot dogs. They sold this many of them. They're selling for 8 hours. Um, so let's see. What we need to know is how many hot dogs they have left. It's unknown by defining a variable. Yeah, I'd say let's do H for hot dogs that are left. We'll divide it by 8 hours. I guess they just define a variable. It's just what it says. So H equals hot dogs left. Is there any irrelevant information? Yeah. Let's see. We don't need the name of the high school. That's not needed. We don't need when it was founded. Um, don't need to know what the fundraiser is for. We don't need to know which days they're selling. We just need to know that they sold on a day and they're going to sell more on another day. So yeah, yes, lots. Okay. I'll let you do that one yourself. Going. The wire. So this is the second principle. So the first principle is understanding. The second one is planning. So we're going to do plans. Probably won't complete these problems, but that's okay. A wire 20 centimeters long is cut into two pieces. The longer piece is 4 centimeters longer than the shorter piece. So one of them is a piece that's short, and one of them is a piece that's 4 centimeters longer. And they total be 20. Do not solve. Instead, draw and label a picture of what these wires might look like in relation to each other. So here's the 20 centimeter wire, and we'll go a little more than halfway. Here's the X, and here's the X plus 4 side. That's good enough. I guess they just wanted the picture labeled like this instead of a Y. Okay. Peter tends to, I guess we should read the goal first because we didn't need the equation, we just needed the picture. Do not solve. Devise a plan to determine the number of goats and sheep that Peter. So I would say an equation counts as a plan if you want it to. Peter tends a total of 87 sheep, so there's 87 total sheep and goats. He had 15 more sheep than goats. So if we have this many goats, then he has 15 more than that for sheep. And if we solve this, that's not how we solve. Solve that. That's the plan. That solved. That's a complete solution to that. Okay. Let's see what it says to do. Determine what Jamal must figure out before he can begin to solve this problem. Not a question, that's a statement. Determine what Jamal must figure out first before he can begin to solve this problem. Okay. Um, Jamal's mom tells him he is 5 inches taller than twice his height when he was 3 years old. He wants to figure out how tall he was when he was three. So, yeah, says that his height now is 5 inches taller than twice his height when he was three. So this is how this is the height at three. Height now is 5 inches more than twice the height at. That was my cat running to get. Okay, so this is his height now. If he knows how tall he is now, we can solve, or if we know how tall he was at three, we can solve. So, but either way, he either needs to know the height now or the height at 3 years old. If he doesn't know one of those things, he can't find the other. But if we knew one of those things, we could plug in that value and find the other. This is a good skill too. Being able to know when you don't have enough information to solve a problem is very valuable. In this problem here, we do not have enough information to solve for anything. We we're missing information, and if we just had one piece of information, we could find the other. But we don't have either piece of information, so we don't get to know anything. Okay. Clarice raises free-range chickens, so do I, both hens and roosters. She sells the eggs, so she likes to have 4 times as many hens as roosters. This is a very low number of roosters for chickens. Usually you want to have like between 8 and 12 hens per rooster, otherwise the roosters fight. Um, she knows she currently has 45 total roosters and hens, but has forgotten how many of each chicken she has. She draws and labels the model to help her make sense. So for every one rooster, she has 4 hens, and so this is this has got to be awful for colorblind people, because those colors, like, I mean, they're only different in colors. Let's call these H's because hens, and the other ones we'll leave as R's because okay. So for every rooster, there are 4 hens. So if R is the number of roosters, 4R is the number of hens, and that has to add up to 45. Write an equation based off Clarice's model that shows the total number of chickens she has. Yes. Number of roosters plus number of hens, which is 4 times the number of roosters, equals 45 total chickens. I want to solve this one just because I like chicken. 5R equals 45, and R equals 9. Okay. We're skipping the third principle because the third principle is to do the plan, which is what the entire rest of the module is. You know, we spend we spend 6 subsections doing the, the doing part of the problems, and then module subsection 7 um, is the one where we focus on the other 3 principles. So principle 1 is understanding a problem. Principle 2 is planning a solution. Principle 3 is doing the plan, which is all of the calculations. Number 4 is reflecting, see if we have a reasonable answer. This is what we were prepping for up here when we did these upper and lower bounds. So knowing that Alexis drove somewhere between 0 and 256 miles, once we do the calculation, we compare against any sorts of bounds that we estimated to see if we did a reasonable, if we have a reasonable answer or if we need to retry. The area of the rectangle is 48 square centimeters if the base of the rectangle is 12. So draw a rectangle, have 48 centimeters for the area, and the base is 12. We don't know the height. Think what units you should use in your answer. Okay. So if we have 48 centimeters squared and we have a side that is centimeters, we know that we have 12 centimeters times something equals 48 centimeters squared. We have centimeters times something equals centimeters times centimeters. This means that this something has to have centimeters in it. Our units should be in centimeters. And that matches with we have a length and we have a height. Those are both one-dimensional. We have length and length equal length times length equals area. We have, and I don't mean the length of the rectangle times the length of the rectangle. I mean that the side of a rectangle has a length, and the other, this side of the rectangle also has a length. the length of this side is x. When you multiply two lengths together, you get area. Should have centimeters as our units because we are looking for a length. Students in Miss Jones' class were making frequent errors in solving equations. Help analyze their errors. Examine the problems below. When you find the mistake, circle it, explain the mistake, solve the equation correctly. So here we have this. They divided by 6. They got t equals 5. But they forgot that negative. Divided by negative 6 on both sides. 30 divided by negative 6 is negative 5. So got negative 9. Correct solution process. Negative 6t 30 t 30 over negative 6. Same thing. Oh, part of reflecting is error correction. So what we should look for when we're doing step 4 is looking for, were there errors in what we did? Did we learn anything about how to do this type of problem that would help us do it more efficiently in the future? Um, we have to look for, does our answer seem to be reasonable given any estimates that we did in the problem process? If we do a math problem and don't learn something from it, did we really um, do anything useful? Anyway, I mean, we might have solved a problem that we needed to solve, but it should be more than just I want this solution. It should be I want this solution and I want to improve in my ability to solve problems in the future. So we have this. Let's see what they did. They subtracted 8 from both sides, and that looks correct. They got a negative sign. So they should have divided by negative 5 and gotten positive. Again, got negative. Correctly, minus 5c, negative 37, negative 5c, negative 45. D equals negative 45 over negative 5, 9, 9. Let's skip down to the last one. Skip to the last one in this section. Negative 2. Oh, let's see what they did wrong first. Yeah, they distributed, but they have a negative times a negative should give us a positive. That's that's one error. They may have made more. They add 4 to both sides. They divide by negative 2, and they get the wrong answer. This is the only mistake I see. It carries through, but that doesn't mean that there are more errors. So got distribute negative sign. So we could do this the way that they're starting. Divide both sides by negative 2, we get x minus, oh, sorry, the way that they're doing it, they're multiplying negative 2, they're distributing. Negative 2 that a little closer. 2x plus 4 equals 14 gives us negative 2x. 10, x equals negative 5. But we also could have done it this way. Have negative 2x minus 2. I can divide both sides by negative 2. I get x minus 2, negative 7. And then I add 2 to both sides. And I get x equals same thing. Kind of up to you. Apply the full Polya process to solve an application problem. The length of a rectangle is 3 units. The width of the rectangle is given by the expression x1. Draw and label a picture that represents the dimensions of the rectangle. Go. You could also draw it this way, but it doesn't. Write an expression in simplified form that represents the area. So the area would be the length times the width, area. Perimeter is going to be 2 times the length plus 2 times the width. Perimeter. This is also equal to 6 plus 2x plus 2. Getting this through, multiplying these together, gives us 2x plus 8 our perimeter. Oh, and it says simplified. This is factored, which is simplified is just not a great term because depending on what you're doing, different things are simplified. But let's assume that they mean that we want to multiply this out. Get 3x plus 3, all of that. X equals 4, use these expressions to find the perimeter and area of the rectangle. Area equals 3 times 4 plus 3, which is 12 plus 3, which is 15. The perimeter equals 2 times 4 plus 8, which equals 8, which is 16. How should you write the units for the perimeter and the area? You expect the perimeter or area larger? Plus units. It says units. So we would assume that perimeter is in units, area is in square units. And area equals 3x plus 3, perimeter equals 2x plus 8. I would say that for most of the rectangles, the area will be bigger because the area is on the order of 3x instead of 2x. For most rectangles in this situation. What I mean by that is that um, the area and perimeter, the numbers will be equal at a certain x value. We can calculate that by setting them equal to each other. This is not part of the solution, by the way. Like, I'm switching over from a statement that answers this question to just something I think is interesting related to this problem. So if we set the perimeter and area equal to each other like this, subtract 2x from both sides, we'll subtract 3 from both sides. When x is 5, the area and perimeter are going to be the same, which means that when x is bigger than 5, the area will be bigger than the perimeter. And then when x is less than 5, the other way. The other way around. Since we're not allowing rectangles with negative side lengths, that means that on the number line, for 0, 5, here up, all of those rectangles with those x values have a than um, bigger area than perimeter. And this goes all the way up to infinity. But in this region here, between 0 and 5, this is where it has a bigger perimeter than area. So for this region, perimeter is bigger than area. For this region, area is bigger than perimeter. And at 5, exactly, these uh, that's when these rectangles have the same area as perimeter. That's what I mean by most of these rectangles have bigger areas because 5 to infinity is a longer interval than 0 to 5. Let's see. Looks like we have Jason and Sean question about running. We have a bag of marbles. Marble questions are fairly typical. They represent well the type of problem that we're doing right now. So I'm going to do the marble question. I'll let you do the running question on your own. A bag contains 67 marbles. There are 3 more white marbles than there are red marbles. So this R is the number of red marbles. That means that 3 more white than red means that number of white is R plus 3. There are twice as many blue marbles as red marbles. That means the number of blue marbles is 2 times R. How many of each color marble are in the bag? Okay, so this is the setup. R number of red marbles, and then the other 2 numbers we have. Using the information from part A, write the algebraic expression containing the variable R that represents the situation. Red plus white plus blue, that's our total, which is 7. Use the equation, that's as much as I can, I guess. Use the equation in part B to answer the question about how many. So this is Polio step 1, where we understand the situation, we gather information and organize it. This is step 2 in the process, where we make a plan. We're going to solve this equation to find the answer. This is step 3, where we do the plan. I combine like terms. R plus R plus R. R plus R plus 2R is 4R. Subtract 3 from both sides, so we get equals 60. R equals 15. And that means that R plus 3, 19, and 2R is 32. So this is the red. This is the white. And this is the blue. I labeled correct. White is R plus 3. Yes. Blue is. You label your answers. Yes, I did. Um, sum of your answers equal to the total number of marbles. If we did it wrong, when we add these numbers together, we'll get something other than 67. 9, and 32. 9 plus 16 is 15, plus 2 is 17. Oh, I had 9 there instead of 19. 9 plus 6 is 15. plus 2 is 17. That brings a 1 up here. 1 plus 1 is 2, plus 1 is 3, plus 3 is 6. Okay. So, is the sum of the marbles equal to the total? Yes. That is the end of the lecture notes. So, I will end this video and upload it. And then I will do 2 more hours of other things and upload those videos. So, I will see you in class today and hope this video is helpful. Have a great day. Bye.